Okay, last time we have finished the topic of ethics and professionalism. Today we are going to start with the new topic of engineering design methods. Okay, engineering design methods involve developing something new. Okay, any process, any method after which you will come up with something new will be called as a design method. Okay, that something new could be a product, like the chair, like the table. Okay, it's a product, right? You can touch it, you can see it. Okay, it could be a system, like a software, or a smart app. Okay, these are what? Systems. Okay, or a program. You are doing the program for this assignment, right? Okay, so it could be a system. Okay, system comes in these categories, or it could be a process. Okay, process to, for example, process to arrange the classes. It's a process. Okay, process to hire the employee for your company. It's a process, right? Okay, so it could be a process. Okay, so if you are doing anything new, then you need to design it. Okay, and that something new could be a product, it could be a system, it could be a process. Okay, in all cases, your design should involve a systematic approach. This is the main difference between engineering and maybe an artist or an architect. Okay, when an artist is designing something, when an architect is designing something, they could be as innovative as they want. Okay, but when an engineer is designing, they have to show that their design works. Okay, whatever they have designed will work, or it will be successful. Okay, so I cannot just design anything. For example, a painter comes and he designs a sun right on the chair. He can do that, right? Okay, he's just designing. Okay, he's just showing his innovation. Okay, but I know the sun will not fit on the chair, right? Clear or not? Okay, so engineering design must involve a systematic approach to show that whatever we are designing, it is new, but it will still work. Okay, it will still be successful. Clear? Okay. The design process involves several stages, and these are mentioned here, including problem definition, research, concept generation, evaluation, design, testing. We will go through them later on in details. In civil engineering, the design process includes three main stages, three main steps. Okay, we have the planning stage, we have the design stage, and we have the construction or the execution stage. Okay, so first of all, we plan. Okay, why we are doing the project, what are we trying to achieve from the project. Okay, what are the different solutions for this problem. Okay, what are the different methods of designing this project or working on this project. But this all comes under planning. Okay, then we do the design. After you have planned what you want to do and how you want to do, then you will prepare your detailed plan, or sorry, design. Okay, you will prepare your detailed design. Okay, the column dimensions, the steel, the height, the width, the material, the strength of material. This will all come under design. Right? And then the next one is the design is final. We will give it to the contractor or the client and you start the construction. Clear? Okay. These are three main steps of civil engineering design. Now you may be covering different aspects of design. In civil engineering, the design is for different aspects of the infrastructure. Okay, I mentioned infrastructure earlier as well. As civil engineers, this is our main responsibility. Our main responsibility is designing, constructing and maintaining the infrastructure. Okay, clear? What is infrastructure? Give me an example of what comes under infrastructure. Water pipelines, okay. What else comes under infrastructure?
The foundation.
The foundation, okay. Yes, what else comes under infrastructure?
The road. The road.
The roads. Okay, anything else? Anything in this room? Electricity, it comes under infrastructure. Okay? In fact, everything around you comes under infrastructure. This building is what? It's infrastructure. Okay? These lights, these chairs, they are what? They are under infrastructure. All this is under infrastructure. All this is infrastructure. Got it? Clear? So, you may be involved in designing different aspects of the infrastructure if you are a civil engineer. Okay? Some of these are mentioned here. For example, you may be involved in structural analysis and design of the infrastructure. Okay? What does it mean? It means structural analysis or design means that you make sure that your product, your infrastructure will be safe under the load. Okay? The structural analysis involves working with the loads. Okay? So you estimate how much load is coming and how much load the building can bear. Okay? So this is under the structural analysis and design. And your building can be anything. I'm just saying building just to differentiate. But it could be a building, it could be a bridge, it could be a dam, it could be a road, anything. Okay? So in structural analysis and design, you are dealing with the loads which are coming on your infrastructure and how the infrastructure will take it. Got it? Clear? Okay. And we are looking at three things in structural design. We are looking at that the building under the load should be safe, it should be stable, and should be durable. Okay. Your structure should have all these three aspects when it comes under the load. It should remain safe, it should remain stable, and should remain durable. Okay. What does it mean? So when the load applies to the building, okay, for example, you design a building for or you design the load, the bridge for the vehicles, right? The bridge for the vehicles, okay? And the truck comes on the bridge and it falls. Is it safe? It's not safe, right? It cannot take the load. When the load comes, it is failing. Clear? So it is not safe. Clear now? Okay. Now let us look at this chair. What do you mean by stable? Okay. Now see, if I apply the load to the chair, is it breaking? It is safe, right? It is safe under the load. Okay? But is it stable? Is it stable? It's moving, right? It's not stable. Do you want the bridge to be like this? No? The truck comes, the bridge is going like this. It will be fun, right? But it's not good. Okay? So when the load comes, what do you want? You want the building or the infrastructure to remain stable. It should not move too much, right? It should not fall, it should not fail, and it should not move as well, right? Clear or not? So I'm moving on this floor. Is it moving? No. Okay, so it is stable. Got it? You get the difference between stable and safe. Safe means that it can take the load. Stable means it can take the load and remain in its position. Got it? Clear? And the last one is that it should be durable as well. Durable means it can take the load for long duration. Okay? It can take the load for long duration. Okay? So, yeah. The building can take very heavy load now. But if I apply the same load for 20 years, Can it keep on taking it? Will it keep on taking the same amount of load for the next 20 years? This is what we call as being durable. Okay? If it can take the same load for 20 years. Some of you go to the gym, right? Anybody? You go to the gym, right? Okay? So people who go regularly there, you may see someone who comes for the first time and he will pick very heavy load and he will start doing it. Okay? It happens, right? Okay? If you go to the gym, it happens. Okay? Somebody comes for the first day, he picks a very heavy load, 10 kg or something, and starts doing it. And he's doing it very comfortably, no problem. Okay? The others are doing 5 kg, who are there for 10 years, and he is doing 15 kg, 20 kg. Okay? He is comfortable. Okay? Or she is comfortable. Okay? He goes back home. Okay? Do you know what happens with this guy the next morning? I have a very good idea. Keep on doing this. You know what happens with this guy the next morning?
It cannot open hand.
Yeah, they cannot move at all. The hand does not move. Yeah. He took the load of 20 kg for the first time. That's fine. Okay? But to keep on doing it for the next 6 months, you need to have durability. Okay? You need to build your muscles so that you can take that much load for the next 6 months or 1 year. Yeah, you can do it one day, no problem. It's safe. Okay, you did not break your bone. Yes, your bone can take it. Okay, but can you do it for the next 6 months? Okay, that is what we call as durable. Got it? Clear? Okay. So this is part of structural analysis. Then we have geotechnical engineering. Geo means earth. The word geo means earth. Okay. So geotechnical engineering deals with the earth, the ground. Okay. The conditions of the ground. Okay. Now if I have built this building, right? Okay. We have our load on this building, right? We are sitting here, our load is on this building, right? And the building has its own weight, the weight of the walls and the projector and the chairs, right? Where is this load going in the end? To earth, right? To the ground. Okay. So this becomes our most important part of the structure. This becomes our most important part of the design, right? Because whatever you're designing, it's a bridge, it's a building, whatever. Okay. Eventually, the complete load will go where? To the where? Now I'm asking you, where are you? You are here with us. Okay, where does the load go? Yes. To the ground. Where does it go? To the ground. Okay. So this becomes the most important part. Okay. If the ground is soft, okay, then we call it soil. Okay. If it is hard, then we call it rock. Okay. It could be soil or it could be rock. Okay. It can be any type, right? We cannot control the ground, right? It's natural. We cannot control it. Okay. So in geotechnical engineering, based on your ground condition, you will change your design. Because I told you the load has to go to the ground, right? So your design should be according to the ground. Okay. And in some cases, your construction technique will also change according to the ground. The equipment which I will use near the sea is not the same equipment which I will use in a mountainous area. Okay, mountainous area, the ground is very hard. Okay, so if I have to do any excavation there, I will use different equipment. Okay, if I have to do excavation near the sea, so sea, you know the sand, right? What do we have near the sea? Sand. It's very soft, right? So the same equipment is not required near the sea. Got it? Okay. So in geotechnical engineering, you test what type of ground you have, design according to that, do the construction according to the ground. Okay. Foundation, obviously, foundation design to mention. Okay. Where is the foundation? Under the building. Okay. So the load goes to the foundation, from foundation to the ground. Got it? Okay. So in some cases, the soil is not strong. The soil is weak. The ground is weak. So when you apply the load, it cannot take the load. Okay. So in those cases, you may have to do the stabilization of the soil yourself. Okay. You have to apply some method to make the ground strong enough to take your load. Okay. In some cases, you may replace the existing ground and put another material yourself. Okay. So this all comes under soil stability. Okay. Okay, then we have hydraulic engineering. So geo means earth, right? Hydraulic means what? Hydraulic means what? Water, right? So this engineering or this type of design deals with the flow and conveyance of fluids. What are the fluid, right? What are the fluid? Okay. So the flow and conveyance means transporting, shifting from one location to the other. Okay, this is called as conveyance. Okay, so hydraulic engineering deals with the flow and conveyance of fluids. Okay, and mainly water. Okay, we deal as civil engineers, we mainly deal with water, but in this region obviously you will have oil supply as well, right? Oil and gas, we have it. Okay, but most of the times we are dealing with water. So in hydraulic engineering, we are designing channels, pipelines, drainage systems. All of them are related to transporting the material, transporting the fluid. Okay, pipelines and channels and drainage systems for the transporting of the fluid or the water. Okay, and then we need some structures to store them, right? We need some structures to transport them and need some structures to store them. Okay, so for example, you may have a dam, you may have a levee, you may have a tank. Okay, so all of them also come under hydraulic engineering. So in hydraulic engineering, we are dealing with systems which will transport the fluid and systems which will store the fluid. Okay, two types. Okay, now here you can see we have channels and pipelines. Okay, they are used general terms. They can be applied to gas or oil or water, anything. Okay, but when we say drainage system, it means mainly for water. Drainage system is mainly for water. Okay, this is the transport mechanism for water supply. Water, not water supply, like drainage of water. Clear? Okay, some other areas in which we apply the design. The next one is transportation. Some of you already gave the examples of roads and bridges as part of the infrastructure. Okay, so when you are doing the design of anything which is related to transportation, it comes under this field, and it could involve planning, it could involve design, it could involve operation, maintenance, construction, everything which is related to roads, railways, airports, ports. Okay, all of them are related to transportation. Okay, so transportation is not only roads. Airports are also part of transportation system. Okay, ships and ports are also part of transportation system. So all these are included in this field. Then we have the next one, which is environmental engineering. In environmental engineering, we design systems which will protect the environment. Okay, we design systems which will protect the environment. Okay. Now, so for example, we have a factory. Okay, and they are doing some chemical process. After the chemical process, they have their processed water. So the water has chemicals inside it. Okay, can you throw this water into the sea? We should not. Can you throw it on the ground? We should not. Okay, before you dispose the water, you have to do some processing. So that processing comes under environmental engineering. Environmental engineering, we process wastewater and so on. Okay, clear? Okay, another thing is, what about if the factory is producing any gas, carbon dioxide or something? Can you just release it in the air? At least you know. You should know. Carbon dioxide is dangerous, right? Everybody knows that. CO2, dangerous, right? Or you like it? Dangerous. Okay? So if the factory is producing CO2, they cannot release it in the air. They have to control it. Okay? Sometimes they do chemical process to get rid of it. Okay? Sometimes they have to store it and do something. Okay? So this all comes under environmental engineering. Okay? The point is whether it is gas, whether it is water, whether it is liquid, anything. Okay? If it is harmful for the environment, you cannot dispose it in the natural environment. You have to process it, you have to get rid of it, recycle it, whatever. Got my point? Okay. Same thing for solid waste as well. Solid waste is plastic, paper, the waste. Okay. The things which you put in the dustbin, right? This is all solid waste. Okay. So I told you, you may be designing a structure or you could be designing a system. Okay. The solid waste system. How will you collect the waste? Okay, waste is not at one point, right? All our houses and this university and all the schools and all buildings and all factories, they are producing solid waste, right? They have to collect it. Solid waste does not flow, right? Water flows, right? If you make a pipeline, water will flow. If I put a dustbin here, it will start moving. No, right? Clear or not? Solid waste has to be collected. Okay. So, how will you collect the solid waste? Where will you put it? How will you recycle it? Okay. And you cannot put all types of solid waste in the same place. They put plastic differently. They put plastic and paper and they put all these things separately, right? Okay. So, the system for that. It also comes under environmental engineering. Then we have construction engineering. So construction engineering deals with construction. Okay. So in construction engineering, we are doing the planning for construction. This is not the planning of the project. This is planning for the construction of the project. What my point? There is a whole planning we do. Where will you build the highway? How long will it be? This is initial. Okay. This planning comes after you have done the design. Construction planning comes after you have done the design. Somebody already gave you the design. Now you will do the planning. How many people I need? Who should I hire? Who will be my contractor? From where will I get the material? What will be the cost? What will be the budget? Okay. So this is construction planning. Got my point? Okay. So there is a planning for the whole project and there is a planning for the construction only. So here we are talking about only the construction aspect. Okay, so you do the planning and execution of the construction. It will include making the schedule of the project, the budget of the project, and how will you do the testing for the project and so on. Clear? Okay. Then we have the materials engineering. Materials engineering, as you know, deals with the materials. Okay. All materials cannot be used at all places, right? You cannot use the same material for all applications. Right or wrong? So I can use concrete for the walls, but I should not use the concrete for the chairs, right? It will be very heavy. Got my point? Okay. So in materials engineering, we study the properties of the material to see where we can use them. Got my point? Okay. So we study the properties of the material to see where we use them. Which properties are important for us? The first thing is strength of the material, how much load it can take. This is the most important property for us, civil engineers. Got my point? So we study the strength of the material, first thing. Secondly, we study its durability. Okay? Durability means what? I already explained. Durability means what?
Should take load same load and long time.
Long time. Okay? So this material is strong, but can it survive for a long time? Got my point? Okay. Everybody. Clear? Iman. Okay. And the last thing is, what will be the impact of using this material on the environment? What will be the impact of using this material on the environment? Okay. So for example, if you use plastic, right? Okay. Plastic is good for the environment or not? No? Why not? What's the problem with plastic?
It doesn't.
Yes, please.
You can't recycle.
Yeah, okay. You can recycle it. It does not degrade. Okay, it's not a degradable material. If I put plastic here, I come after 10 years, it will still be here. Okay, it will not damage itself. Okay, so this is not good for the environment because you will keep on producing plastic and it will remain there. Okay, so plastic is bad for the environment itself. Okay, what about wood? Wood. Is this good for the environment or bad? Good, right? This is good. I can use it. But does this mean I should keep on using wood everywhere? Because I cannot use plastic? Is there any disadvantage of using wood for the environment? What?
Something very good.
Disadvantage. What is the harmful effect of using wood in my construction for the environment?
Environmental or for the
Environment.
cutting.
Cutting trees, right? So you see, wood itself is good for my project, right? But getting wood is harmful for the environment. Got my point? Okay. Plastic itself is harmful for the environment. Plastic is by itself harmful for the environment. If you are using plastic, nobody will say that it is good for the environment. Okay. But wood is good for the environment. But to use it in my project is not good for the environment. Because to use it in the project, I have to cut the trees, right? To get the wood, I need to cut the trees. Okay. So there are some materials which are directly harmful for the environment, like plastic. And there are materials which are indirectly harmful for the environment because their production is harmful for the environment. Okay. So to produce wood, I need to cut the trees. Got it? Same thing with cement. Cement has no problem with the environment. If you are using cement, it has no problem with the environment. Okay. But to produce cement, the factory uses a very heavy process. It requires a lot of energy. Okay. So cement is good for the environment, but producing cement is not good for the environment. Got my point? Clear? So in material engineering, you look at these aspects as well. Okay. If I use this material, is it good for the environment? And from where I am getting this material? Maybe that process is not good for the environment. Clear? Okay. Okay. This flowchart shows the entire process of design method in general, which is applied to all types of engineering. Okay. So this is for all types of engineering. You start by defining the problem. The problem can be of two types. Okay. The problem can be of two types. Okay. So for example, you go on the road and there is a traffic jam. Problem or not? Problem or not? So you say yes. You guys think so much. Problem, right? Traffic jam is a problem. Okay. So you build a new bridge to remove the problem, right? You remove the problem. Okay. This is one type of problem. Okay. Another problem, another type of problem could be I want to achieve something better. There is no problem right now, but I want to make it better. Okay. So for example, I have a road. There is no problem with the road. Okay. But I want to make the environment of the road better. So I will put trees on the side of the road. Will it make the environment better? Putting trees on the side, will it make the environment better? Yes or no? Okay. But was there a problem earlier? No problem. The road was working fine. Traffic was smooth. Okay. Clear? Clear. The point is clear. Sometimes the problem is there. Something bad is happening and you want to work. Sometimes the problem is I want to make it better. There is no problem right now, but it can be better. Clear? Okay. So problem any type of these problems, then you start brainstorming. Brainstorming means you think. Very difficult, right? Or very easy. You guys are always thinking, right? Huh? Always somewhere in the classroom. So, brainstorming is you think about all possible solutions for the problem. Okay? You are thinking according to your experience, according to your knowledge. Okay? So you think about what can I do? Everything you can do, you will write it. Brainstorm. Okay? So brainstorming means coming up with your own solutions. Brainstorming means you are coming up with your own solutions. Clear? Then the next step is to do research. Research, now you will start looking at other sources of information. In brainstorming, your source was what? Your brain. In research, your source is other things. It could be books, it could be previous projects, it could be other engineers, it could be internet, whatever. Okay? So in research, you are now looking at a wider perspective, a wider spectrum. Okay? Outside yourself. So brainstorming was within yourself. Research is from outside. Okay? And obviously you will cross-check that what I was thinking, is the research helping me with that or not. So I was thinking about making a steel structure. Okay? But now the research is showing the steel structure is not possible. It was used in project X and Y and it failed. What my point? So research will help you to refine your brainstorming. Okay? Clear? So brainstorming your solutions. Research to look at what others have done or what previously has been done and so on and so forth. So research, and then you establish the criteria and constraints. Criteria means the things which will define the success of your project. Okay? The things which will define the success of your project. Okay? So for example, in your case, it's the grade, right? If you get A grade, you will consider yourself successful, right? If you get 4 GPA, success, right? So this 4 GPA is what? Your criteria. What my point? Okay? Or A grade is what? Your criteria. Okay? For a project, it could be that my building should be able to take the load of 200 people at the time. At a given particular time, my building should be able to take the load of 200 people. So the load is my criteria. If it can take 200 people load, success. Clear? Okay? Clear now? Or my pipeline should be able to transport 20 gallons of water per minute. If it transports 20 gallons of water per minute, it is successful. Clear now? Okay? Or my road can handle 20,000 vehicles in 1 hour. If 20,000 vehicles can use this road in 1 hour, it is successful. This is criteria. Okay? What is constraints? Your limits. What are the constraints? Your limits. I want to achieve this, but I have limited time. Okay? I want to make a building for 200 people, but my budget is only 60,000 BD. Okay? So, you understand the difference between criteria and constraint. Criteria is how you define your success. Constraint is what is your limit. Limit could be in terms of money, could be in terms of time, it could be in terms of people as well. Okay? Or resources as well. I need to do this very fast in 6 months, but I don't have the machine which will do it fast. I have to use people. I have to do it manually. Or I don't have the software. Okay? Got my point? So these could be your constraints. Now, remember, in brainstorming and research, you have already looked at different ideas. Now you will apply your criteria and constraint to these ideas, and you will see which idea fulfills my criteria and is within my limits. Okay? So I was thinking about 4 different designs. Out of these 4 designs, only 2 are fulfilling the criteria. Okay? Only one of them is under my limits. What am I? Okay? So I was trying to build a building for 200 people. Okay, I was thinking about concrete, wood and steel. Then I looked at the research and I found that only concrete and steel can hold this many people. If I make it out of wood, it will not be successful. So only two left, right? Wood is gone. Okay. When I look at the cost from the previous projects, I found that concrete is cheap, steel is expensive. So only concrete is under my budget. What am I? Okay. So you will establish your criteria. Then you will go back to the options and you will see which of these options fulfills my criteria and is within my constraints. Okay. Which of these options will give me success within my limits. Clear? Okay. So at this you have selected your final option. Okay, you have selected your final design. Okay, then you start the design. Now you see from here up till here. When did we start the design? Yeah, we did not do the design here, we did not do it here, we did not do it here. Okay, why? Because designing something takes time, it takes effort, it takes money, it takes people. Okay, what am I? If you are designing a bridge, one engineer cannot design the whole bridge. Okay, so you will put 3-4 people together and they will be busy for maybe 15 days, 20 days for designing one bridge. Okay, so I cannot ask them to design for 10 different options. So first I finalize the option, then I tell them, okay, now design according to this option. Okay, so their effort will be less, it will take less time. Okay, so until we finalize our solution, until we finalize our option, we will not do the final design, we will not do the full design. Got it? To save effort and time. Okay, then the next one is you make a model or a prototype. Okay, now you did the design. How will you show the client your design? How do we show it? Tell me. So you made the design of a building. How do we show it to the client? We draw it, right? So our drawings are our models. Okay, and now we have 3D drawings as well. Okay, so your model, even in AutoCAD you can do 3D drawing, no problem. Okay, so your model can be 2D or 3D. Now we have 3D printing as well, right? So you can just draw it and it will print or it will make the model for you, small building for you. Okay, so all these things are possible. Then you test and evaluate. Once you have constructed the building, then you have to do the testing and evaluation, building or bridge or whatever. Okay, so this happens in some cases. Testing and evaluation can also be done through softwares. Okay, so you made your design, then there are softwares. For example, if you doing it for a structure, for a building, you can use a software which is called as STAD. It's a software. You can put the design of your building and you can put the load. It will show you under this load how much stress will be produced in your structure. Okay, so this is testing and evaluation. I did the design, but when I tested in the software, I found that when the load comes, there is too much deflection in the building. Okay, there is too much deformation in the building, too many cracks, for example. So what I will do now, I will refine my design, obviously. Okay, so you make your initial design, you test it in the software. Okay, do the analysis. If there is any problem, then you refine it. Okay, you make changes. Okay, and then the next one is after refinement, you have your final solution. After final solution, you will give the design to the client, the boss, the contractor, whatever. Got it? Okay, is this the final step? No? No, communicating the results. Is this the final step? The last one, this one. Is this the last step? Is there something after this? Is there something after this? Did we discuss all of them? We discuss all of these. So this is the final step. After that, I go where? Again. Okay. So this is a loop. Okay. It's an iterative process. It's an iterative process. Maybe you will show the design to the client and the client will not be satisfied. It can happen, right? Okay. The client may say, no, I was looking for the best building in the whole Bahrain and you made me a box of concrete. I don't like it. Do it again. It can happen, right? Okay. Or it can happen at a different time. Okay. I did this whole thing. Now, after 20 years, I may do the same thing again for the same project. So it can be another loop in the next time. For example, you build a new highway. Okay. So you did all this thing. You gave the result to the client and he constructed it. The road is ready. Okay. After 20 years, you see there are traffic jams on the road. Okay. Now you do the same thing again for the same road, right? You do the same thing again for the same road. Now to solve the problem of traffic jam. What now? Okay. So the loop continues at different times. I'll do it now. After 20 years, I will do it again for that situation. Because after 20 years, things will change, right? Okay. So that's why. Okay. The explanation of these steps are given here. Okay. In the same order. Okay. I just go through the points which are not mentioned in the flow chart. The first one is documentation. Whatever you are doing, it must be documented. Okay. Your plans, your reports, it should be updated. Okay. Before the project, during the project, after the project. Whatever you are doing, you will report it. Okay. If you did any tests, you have to keep the record of the tests. You did any surveys, keep the record of the surveys. You made any drawings, any changes in the design, all of that should be documented. Got my point? Okay. Who was the people used on the project, how much was the budget, how much was the time and so on. Okay. Why? For future reference. Okay. I gave the example of the road, right? So I see a lot of traffic jam on the road, so I decide I will make a new bridge. To make the new bridge on the same road, I need the previous drawings, right? Right or wrong? Without the previous drawing, I cannot make the new bridge. I have to make it from the scratch myself. It will waste a lot of time. Okay? So the previous documentation will help me make the new project, right? Will help me for the new project. Clear? Okay? It will also help you to improve your design for future. Documentation will also help you to improve your design for the future. For example, when you were doing this project, you had a problem. You had a problem with the material, for example. And you solved this problem. 10 years, after 10 years, now you are not in this project now. You are in another company. Okay? After 10 years, somebody else is doing the renovation for this project. Okay? Renovation, rehabilitation for this project. He doesn't know what happened last time. He may make the same mistake and may waste the same amount of time again. Okay? But if you did the documentation, he can go to the project report and he can see what happened last time. So he will not make the same mistake. Got it? Clear? So documentation is important for that. Feedback and iteration. So after the project, you take the feedback from all stakeholders and users. Okay? So you are the users of the building, right? You are using the building. Okay? Did you construct the building? Did you design the building? Say Alhamdulillah. That's why we are still here, right? Who knows what will happen if you do it? Okay? But you are the stakeholder, right? Person who designed it is a stakeholder. The person who constructed it is a stakeholder. The person who is maintaining it is a stakeholder. Okay? So after everything is done, you take the feedback. You know the feedback, right? They do it everywhere, right? You go to a restaurant, they will come, give us the feedback. You use Google Maps, they say, okay, give us a review. It happens, right? But for the project, it's very important to know, again, for future reference, okay, it should be done for all the stakeholders, okay, client, the boss, the engineer, the labor, whatever. Okay. Another thing which is not written, so these points are not written there. Okay, I'm just explaining because they are not part of the feedback. They are not part of the flow, but they are there. Communication is very important. All parties must communicate with each other constantly from the start to the end. Okay, all of them should know what the project is about and what is happening on the project. Okay, I told you. First thing is the client is thinking about a villa and you are thinking about a apartment. There is miscommunication, right? The client is saying something else and you are doing something else. Will it work? No. So communication is very important to make sure everybody is in the same alignment. Everybody is thinking about the same thing. Okay? And secondly, they know what is happening on the project. Everybody knows what is happening on the project. Is it on time? Is it under budget? What material we are using? What technology we are using? Who is the person who is working on the project? Who is the manager? Who is the CEO? And so on. Clear? Okay, so communication is very important, and following the process does not mean you cannot do something new. You can do something new, but you have to follow the same process. Okay, you can use a new material, no problem, but still do the market research, do the evaluation, do the testing. All these things are important. What my point? Okay, so innovation can be done, but procedure is still important. Okay, any questions?